Okay, so what we've been waiting for now is chemistry ATP. So chemistry ATP paper 6. This is going to cover all the main points. I'm going to do this fast today because it's late and I need to finish a couple things. But anyways, without further ado, let's start. Okay, so now the most important things to note is the apparatus. Apparatus are very important. They they ask you always in the first 2-3 pages about the apparatus and how they are used in experiments. For example, let me give you the most common example. We have three things here. We have, as you can see, the pipette, we have the burette, and we have the measuring cylinder. Now these three are all different. No, I mean they're used for the same purpose. They're all used to measure liquid. However, when you have to know that the burette is the most accurate one out of all of them. The burette is always the most accurate. Comparing to the measuring cylinder and even to the pipette, the burette is the most accurate. The measuring cylinder is the least accurate. And the pipette is in between. Now, one thing about the pipette is that you have to know it cannot measure different volumes. So imagine in an experiment we are using like 25 centimeter cube and then we're using 50 centimeter cube. Again, we cannot use a pipette for this. We have to use a burette or a measuring cylinder, because a pipette cannot measure fixed volume. It can only measure variable volume. Sorry, I meant it cannot measure variable volume. It can only measure fixed volume. Like if we only have 25 centimeter cube of one substance, we can only measure 25 centimeter cube. We can't go up or down. And now, if it asks you an advantage of using the burette over the measuring cylinder, we always have to say that the burette is more accurate. However, if it goes the other way around, for example, if I say, what is an advantage of the measuring cylinder over the burette, or even measuring cylinder, or what is a disadvantage of the burette, for example, or disadvantage of the pipette? For these two, the disadvantage is that they are slow. What do you mean by they are slow? So you know when the liquid comes out of here, the liquid will come out slowly, so that you know that the reaction will start without even all the liquid will come down. So you have the disadvantages. Oh my god! The disadvantages for them is that the burette and usually the pipette. But if it asks you a disadvantage of the burette, you can say that it is slower than the measuring cylinder, because the measuring cylinder you can directly pour. However, if we're going to talk about accuracy, the what's it called? The burette is the most accurate. Now, away from these three, now let's go to something we call as pestle and mortar. Pestle and mortar, you can see it is right over here. This is always used when you want to crush anything. For example, I have a big piece of ore, a rock, an ore for example, and I want to crush it into a powder. And I will show you an example of an experiment that will implement this. If you want to crush an ore into a powder, you have to use pestle and mortar. So if you write in your investigation, crush the ore or the rock using pestle and mortar, that will get you automatic 2 marks. Pestle and mortar, as you can see, they're always used for crushing anything to do with that's not a powder, or like any large lump of something that needs to be crushed. You crush it using pestle and mortar. You can use hammer, but the recommended is pestle and mortar. Now, beaker here is also very important, but it is pretty self-explanatory. The beaker is used to hold the volumes of anything. So if you see a beaker, make sure that you say it is a beaker. Conical flask. The conical flask always looks like a triangle. So if you see something that looks like a triangle, smooth edges, but if it looks like a triangle, it is a conical flask. You're not gonna see much of these or this. You're only mostly going to see the conical flask. And also, what is very important is the stirring rod. Yes, this stirring rod will always, or most of the time, it will ask you what is this called, or why we stir Why do we stir using a stirring rod? Now the reason why we stir is to mix the reactants. The reason why we stir is to mix all the reactants together. We want to always make sure that we mix the reactants together in an experiment. And we use that using a stirring rod. The funnel is used for filtering, of course. We use filtration, we filter with funnel. Balance is used to measure the what's it called, mass or weight of anything. The gas syringe, of course, gas syringe is very important. If you're going to do anything, use it to collection of gas. For example, I want to collect carbon dioxide from anything. If the reaction here has hydrochloric acid and some sodium carbonate and carbon dioxide, this is not sodium carbonate, sodium carbonate, and then carbon dioxide forms, then we will collect it using a gas syringe that will look like this. This is the gas syringe that we use to collect the gases. If it asks you to collect gas, how to collect gas, use a gas syringe. And even in investigations you can say it, and this can also apply to biology as well. They can ask you how do you collect the gases, you can say using a gas syringe. Of course, what is also important is a test tube. This is either you call it a test tube or boiling tube. However, I recommend calling it a test tube because that is the well-known name of it. A test tube is pretty self-explanatory. Stopwatch is also pretty self-explanatory. We have now as well a thermometer to measure temperature, and yeah, that's pretty much it. Now here, not everything you need to know, because there's a lot of the investigations that come from past papers from previous years. However, there are some that are like more important than others. I will give an example. Acid-base titration. Yes, this is very important. Titration. So titration is basically you're going to use a burette and you're going to use anything like a beaker or a conical flask. Now this titration is usually we call it acid-base titration. So what will happen is either the acid or the base will be in the burette, and we can say, for example, the acid will be in the flask, or this can also be a beaker. And we're always going in acid-base titration, we always use something we call as an indicator. An easy indicator to memorize, I find it the easiest to say, is methyl orange. You never use universal indicator, you always use something like methyl orange or thymethylene, but easy to pronounce and write, I'd say use methyl orange. And please memorize the colors. Methyl orange, because we have two like kind of colors, alkaline and in a acidic solution. In an alkaline the color is yellow, and in an acidic solution the color is red, and in a neutral solution the color is orange. Make sure this is memorized. Now, in an acid-base titration, we were going to basically slowly start pouring if this was, for example, a base, we're slowly going to start pouring the base into the flask until we see the end point, which basically means the slight color change. The slight color change, you see, we call it as the end point. We have to make sure to observe the end points here. And yeah, that is basically acid-base titration. Now, that is how you plan it. Basically, plan it as you want. This can be anything. This can be a beaker. This can be a flask, a conical flask. And here, this must be a burette. And you can either put the base here or the base here, acid here, but it has to be acid and base titration. And you have to use an indicator. Now we also have to memorize. And now the most important thing is the tests. The tests for, yes, here. So the cation tests. The tests for cations. Now we have two tests for cations. Adding sodium hydroxide in excess. Or just adding sodium hydroxide and then also adding it in excess. And we have ammonia, which is NH3, and we also add that in excess. So there are two different results to when we add it in excess and when we don't. So for example, this table here, we have copper. Copper, if we add any of these two in excess, sorry, not in excess, if we just add them, for example, sodium hydroxide, if we add it to copper, we're going to get a light blue precipitate or a pale blue precipitate. Better to say light blue. Precipitate is what you're going to get. For iron plus 2, you're going to get a green precipitate. For iron plus 3, you're going to get a brown precipitate or red brown. And for aluminium, zinc, and calcium, you will get a white precipitate. Now, there's going to be a difference if we add the sodium hydroxide in excess and the ammonia in excess. Now, copper, if we add sodium hydroxide in excess, copper does not dissolve in sodium hydroxide in excess. It only dissolves in excess ammonia to form a dark blue solution. This is for copper. Yep, so adding the sodium hydroxide in excess, again, copper does not dissolve, but copper dissolves in excess ammonia to form a dark blue solution. Iron plus 2, both the irons do not dissolve in anything in excess. They dissolve only in not excess, so if we dissolve it in sodium hydroxide and ammonia, they will dissolve. However, if we dissolve them in excess basically if we add extra amounts of ammonia or sodium hydroxide, they will not dissolve. They will not dissolve. Okay, so this is the and by the way, so we have aluminum, zinc, and calcium. These three dissolve in sodium hydroxide and in ammonia to form a white precipitate. Now, how do we distinguish from them? How are we going to distinguish them? So what's going to happen is we're going to add excess amount of NaOH, which is sodium hydroxide, and excess amount of NH3, which is excess amount of ammonia, NH3. So once we add the excess NaOH, which is the sodium hydroxide, only the aluminum and zinc will dissolve in excess. The calcium does not dissolve in excess to form a colorless solution. Aluminum and zinc are the only ones that will dissolve in excess. And then we have calcium, which will not. When we add ammonia, only zinc will dissolve. Aluminum does not dissolve in excess ammonia, and calcium does not dissolve in excess ammonia. And you have to mention that it dissolves to form a colorless solution. Again, these all form white precipitates, but when we add NaOH in excess, aluminum and zinc only dissolve, calcium do not dissolve, and when we add ammonia in excess, zinc dissolves. Okay, so now the important tests for calcium, for carbon dioxide or carbonates, both of them, this test applies. So how do we test for carbonate or carbon dioxide? Okay, so we're going to have to bubble the gas. We have to bubble it through something called lime water. Now, if the gas is carbon dioxide or carbonate, it will turn the lime water milky. And you always have to know, in every reaction, if it asks you an observation of carbon dioxide or a carbonate, you have to mention that there will be fizzing. You know how Coca-Cola or any fizzy drinks, they have all carbon in them, so you have to or carbonates, you have to mention the fizzing. The fizzing is very important. Fizzing or effervescence, but fizzing is an easier word to spell. So you have to mention their fizzing. Now, for what's it called? Halides, we have 3 halides. We have chloride, iodide, and bromide. Now, to test for them, we have to add, first of all, we have to acidify with nitric acid with NO3 negative, or nitric acid. Oh my god, it's -1. Okay, and then we have to add silver nitrate. Okay, now how do we distinguish from this test? Chloride will always have a white precipitate. Bromide will always have a cream precipitate, and iodide will always have a yellow precipitate. Okay, so that's it. That's basically all you need to know for this. Nitrates, we have to add sodium hydroxide and add aluminum foil. How you will know? Okay, see. What happens when you do this and a nitrate is present? Basically, ammonia gas will start to release. And to test for ammonia, you need to get damp, which means wet, litmus paper. Okay, so if ammonia is released, that means the nitrate is present. Okay, so to test for ammonia, we need to place the damp litmus paper, and if the damp litmus paper turns from red to blue, that means we have ammonia is present. That means the nitrate is present, because when we do this reaction of adding sodium hydroxide and aluminum foil, it will release ammonia, which to test for ammonia, we need to use damp litmus paper, which will turn from red to blue. Okay, and now we need to, for sulfates, we need to add acidify with nitric acid, which just means just add nitric acid with nitric acid. And we have to add barium nitrate solution. Okay, so and our result will be a white precipitate. A white precipitate will be our result. Okay, so when it asks you add what's it called, any sort of sulfate, SO4, even if it says add sulfuric acid and there is barium nitrate, so add barium nitrate and acidify with dilute nitric acid, your result will be a white precipitate. What precipitate basically means solid. Now, to test for a alkene or an alkane, we need to use something called bromine water. Okay, see, so an alkene, which basically means I have a double bond, and an alkane means I don't have a double bond. Yeah, so the alkene has a double bond because you see there's an E. If it's spelled alkene, then there is a double bond. If it's spelled alkane, then we have a single bond. Now, bromine water. If we add bromine water to an alkene, which has a double bond, it will go from orange to colorless. Okay? Orange to colorless. But if we add it to an alkane, the color will just remain orange and it will not change. So it will just stay orange. Nothing will change. And by the way, you need to make sure, oh yeah, there's one more test that you need to know for the exam. Oxygen. Oxygen, if we have a splint, like a match, not lighted, but it's just glowing, the oxygen will relight a glowing splint. And it will burst into a flame. It will relight it. And also this means that it is flammable. So whenever oxygen is mentioned, you have to write the test if it asks for it, and if it says, for example, the properties of this, you have to say it is flammable because it causes fire. Now, also very important, you have to know NH3, ammonia, which is NH3, and we have what do you call it? Methane are toxic, and methane methane is flammable. So if it asks you that why the experiment is taken in a fume cupboard, why the experiment is taken place in a fume cupboard, why the experiment takes place in a fume cupboard, it's called a fume cupboard. Basically it prevents any gas from escaping. The reason why is if it says ammonia, then you will say since ammonia is toxic. If there is methane, then you will say methane is flammable. Okay, that's it. these are the indicators, colors. So an acid, methyl orange is red, and an alkali it is yellow. Alkali is base or soluble base. Fine orthethylene, it is colorless in acid and pink in alkali. Litmus paper is red in acid and blue in alkali. Okay, now back to the example question. So you want to now know how are we going to actually solve? How do we apply what I just said? I will show you. And most likely these questions will be the ones to come in the exam, I think. Most probably. Okay, so solid O and solid P were analyzed. Solid O was ammonium bromide. Now ammonium bromide, ammonium, which is NH4, do not mix ammonium. Ammonium, which ends with UM, and ammonia, which ends with an A, are different. Ammonia is NH3, this is NH4 positive. Okay, and it says ammonium bromide. Tests were done on each substance. Now let me tell you something. When we add sodium hydroxide to ammonium, the gas ammonia will release. Ammonia gas will be released. Will release. And to test for ammonia, I said we need to use something called litmus paper. So if it mentions anything to do with adding sodium hydroxide, and what you will observe if that is added, you will say it turns red litmus paper blue. Red litmus paper blue. Okay, so now let's read the question. Ammonium bromide. Tests were done on each substance. Complete the expected observation. Solid O was dissolved in water to form solution O. Solution O was divided into 4 approximately equal portions from 4 test tubes. Now, to the first portion of solution O, approximately 2 centimeters of a cube of aqueous ammonia was added. Okay, so since ammonia is ammonium and ammonia, they cannot react together. Ammonia and ammonium do not react together, so we just need to write no change or no reaction. Both are correct, no change. That gives you 1 mark. Okay, so now we have to the second portion of solution O, approximately 2 centimeter cube of aqueous sodium hydroxide was added. The mixture was warmed. A gas was given off. Now it says sodium hydroxide, and when we add sodium hydroxide to ammonium, we said ammonia will release. Now it wants observation, so obviously the gas will not come up and say, hey, I am ammonia and I just got released. You're going to observe what you're going to see. So what we observe, because we said the test for ammonia is with using litmus paper. So if since ammonia is released, we're going to write turns red litmus paper blue. And that gives you the 1 mark. Now it says identify the gas given off. We said since adding sodium hydroxide to ammonium will give you ammonia, which is NH3. That's good. Now, to the third portion of solution O, approximately 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate were added. Now, if you remember, acidify with dilute nitric acid, add silver nitrate. This is the test for halides, which is bromide, chloride, and iodide. And here we have bromide. So, we said the bromide, when we test bromide, we will get a cream precipitate. A precipitate means solid, and the color is cream. Now, let's say, for example, we had iodide. It will give you yellow precipitate. And if we had chloride, we will give white precipitate. Be careful, it says add 1 centimeter cube of dilute nitric acid or acidify, and add a few drops of silver nitrate, AgNO3. Silver nitrate. It will give you cream precipitate because this is bromide. Now also make sure to know that bromine color in room temperature is orange. Bromine. Orange. It is a liquid and it is an orange color. So this will help us answer the 4th question. So now when we add to the 4th portion of solution O, approximately 1 centimeter cube of aqueous chlorine was added. Now since chlorine, it will displace bromine, it will take its place, so bromine will be left on its own. Okay, It says if added aqueous chlorine, so bromine, and the color for bromine is orange. So we have to say that the solution will become orange, or we say orange solution slash orange solution. Both are correct answers. Both you get to the 1 mark. Chlorine and fluorine are both gases. Iodine is solid. Fluorine is most reactive, then it's chlorine, then it's bromine, then it's iodine. So chlorine is more reactive than bromine, so it will take its place. Bromine will be left on its own, and it will change the color of the solution. It is orange. It will change the solution to orange color. Now it says here, tests on liquid P. Test 1. A few drops of lighted liquid P were placed in a crucible. A lighted splint was applied to the surface of liquid P in the crucible. So it says it burnt with an orange flame. Burnt. Burnt means automatically your head has to shift to 2 things. Burnt with an orange, that means this is going to be flammable. This gas that we're talking about is flammable. So it burns with an orange flame and lots of smoke. This clearly shows the properties of a flammable gas, which means it's easy to light on fire. And soot was left around the top of the crucible. Test 2. A few drops of liquid P were added to a test tube containing 1 centimeter cube of aqueous bromine. Now, we have to be careful here, because we said the color changes from orange to colorless. So that means that it said that by the way, aqueous bromine is also bromine water. Same thing. And we said the bromine water is tested to distinguish from alkane and alkane. Now we said it says it turns from orange to colorless. Ya Allah. Okay, wait, bear with me. Alkane. Now we said it will turn from orange to colorless in an alkene where a double bond is present. And in an alkane it will stay orange, but here we know that we have an alkene, or anything with a double bond, or we can also call them unsaturated compounds, but no need for that. Now it says what conclusions that we can make about liquid P. Now we know that liquid P, it said it lighted on fire and with an orange flame and a lot of smoke, which means that liquid P is flammable. 2 marks or 2 points. Okay, so second point, we can say that it said the color changed from orange to colorless, which means this is an alkene. So liquid P is a alkene. Since they have a double bond, and an alkene it changes the color from bromine water from orange to colorless. Okay, now the very, very important part. Now we have to pay attention to this. Now it says cobalt is a metal. This is investigation 6 marks. Let's go text now because I need to. Okay. Cobalt is between copper and iron in the reactivity series. The mineral spherocobaltite, contains the compound cobalt 2 carbonate and no other metal ions. Cobalt 2 carbonate is insoluble in water and reacts with dilute acids to form an aqueous solution of a salt. Describe how you would obtain a sample of cobalt starting with a large lump of spherocobaltite. Spherocobaltite. Okay. Now, it says now this is one of the things that we have to analyze now. It wants us to extract cobalt from spherocobaltite, which is an ore. This is an ore. And we said, what is the first thing we do with an ore is we need to crush the ore into smaller pieces. So it says we have a large lump of spherocobaltite. We're going to do? The first thing, la niqash, we're going to crush the rock or crush the spherocobaltite using mortar and pestle. And we just said that mortar and pestle are the things we use to crush anything. We used mortar and pestle. Now with these, just saying this will give you an automatic 2 marks. You have 1 mark for saying crush the rock or the spherocobaltite, and 1 mark for saying using mortar and pestle. Now, let's continue. So we want to, it says, now let's read the question. It says cobalt 2 carbonate. Now what we have now, we crushed it. So now we have powder. We have powder of the sphero-cobaltite. So we have powder of this powder. We have powder now. Now what are we going to do this to this powder to obtain a sample of cobalt metal? We want just the raw cobalt. So the first thing we're going to do, we need to think. So let's read the question. It says the sphero-cobaltite contains the compound cobalt 2 carbonate. Okay, and it says cobalt 2 carbonate is insoluble in water and it reacts with dilute acids to form an aqueous solution of salt. Okay, so we can say, because it says it reacts with dilute acids, so the thing in the powder here, the sphero-cobaltite, it reacts with dilute acids to form an aqueous solution of salt. So what we can do now is we can say add the sphero-cobaltite to any dilute acid. We're going to use hydrochloric acid. Hydrochloric acid in a beaker. Now see how this already, I know this will also give you 2 marks, because you're mentioning you need to add it to an acid and you're mentioning exactly what acid you're using. By the way, you can use any dilute acid, any strong dilute acid. You can say nitric acid, hydrochloric acid, and whatnot. Now what we are left with is, now we have the solution of the cobalt carbonate, which is the thing present inside of the sphero-cobaltite ore. It reacted with hydrochloric acid. So now that will give you cobalt chloride, because you see hydrochloric acid. Yep, so cobalt chloride. Okay. Now we know it says, you have to pay attention, it says cobalt is in between copper and iron in the reactivity series. Okay, and in order to, now what we want to do is just remove the chloride and just make cobalt on its own. Now that's our goal. Okay, yeah, so how we're going to do that exactly is we're going to react this cobalt chloride with a metal that is more reactive than cobalt. So what happens is that that more reactive metal will push cobalt away, it will take its place, and cobalt will be on its own. It will be, for example, if I say we have to name the metal, magnesium, for example. Magnesium is more reactive than, yeah, so magnesium is more reactive. So magnesium is one of the most reactive things. But you can even say iron or zinc or anything that is more reactive than copper, or more reactive than cobalt. So magnesium will react with cobalt chloride, so it pushes cobalt, it becomes magnesium chloride, and then also cobalt on its own. Sorry, cobalt is CO. So what we're going to do, we're going to add, so we're going to write add a more reactive metal than, for example, what's it called, copper, or more reactive metal than cobalt. Yep, so we can just say more reactive than the metal than cobalt, and you have to give an example. So I gave magnesium, so you can say magnesium. So I'm going to increase the size. So magnesium, and then you say copper is then displaced, which means it got pushed out by magnesium and it's on its own and can be collected. Four very easy, very short points to describe how we will collect. Again, first of all, any ore or any big rock, we need to crush it. What we will crush it? Using mortar and pestle. So that's 2 marks. Add the spherical. Okay, so then we want to now to get the sphericobaltite powder. So I can, you know what? Actually, better. Let's just write sphericobaltite or add the powder to hydrochloric acid. Okay. Why do we said we do that? Because it says here cobalt carbonate reacts with dilute acids to form a. So we know that copper carbonate is a reactive. So we react it with hydrochloric acid or any acid, okay, to form a salt. That is step 2, and that gives you 2 marks because 1 mark for the adding the acid, and another mark for naming the acid itself. So you're like nitric acid, hydrochloric, any of that. Okay. I recommend hydrochloric, but nitric acid also works. So that's 2 marks, 2 marks, that's 4 marks. Now we say add a more reactive metal than cobalt, because we want this metal to push cobalt out of the way on its own and take its place, so then it becomes magnesium chloride, and then cobalt is on its own. And we also have a mark, so this will also give 2 marks, because saying that we need to add a more reactive metal will give you 1 mark, and naming the metal itself, what I said magnesium here, will give you 1 mark. So make sure to name the metal. It can be magnesium, zinc, anything above cobalt. And then you get, so that's another 2 marks, so 2, 4, and we already, by the way, we already got the 6 marks. But still, we can add this point to be 100% sure. We have to say copper is then displaced, which means it got pushed and it's now on its own and can be collected, and that is going to be full 6 marks, 100% 6 marks, full, correct, everything, guaranteed 6 marks. And this works for anything that has to do with extraction of ores. Anything with, if it asks you to take this ore out of, or if it wants you to take cobalt out of this, or for example, if it wants you to extract zinc from something, any sort of extraction from an ore will use the same process. And make sure to mention the mortar and pestle. This is very important. This gives you a whole mark for just mentioning crush using mortar and pestle. Okay, so we are done now when it comes in term of these two, and there's just one more thing that I can cover, and you are 100% set for the exam tomorrow. You're fully set, and I am telling you now, full mark. Okay, so now the last part is actually how we're going to apply the apparatus and everything in the experiment. Okay, so in order to apply the knowledge we are just like speaking about, we need to, like the apparatus knowledge and everything like that, we need to actually solve things, solve questions, past papers questions on it. So let's do this. Barium sulfate is an insoluble salt. Barium sulfate can be made reacting excess aqueous sodium sulfate with aqueous barium chloride. All this stuff is, to be honest, extra information, because it will never really like ask you details on the reaction. It will ask you mostly about the experimental part. What is this called? What is this called? Why do we stir this? Why do we do that? So now it asks name the names of the apparatus labeled A and B. Now you see A is this. We said this is what we call a stirring rod. B, as you can see, it's labeled this, and that is a conical flask. Okay, so now it says name the process shown in step 3. Step 3, as you can see here, it's showing you a funnel and a conical flask. When you see a funnel and you see or any sort of funnel with a flask or funnel with a beaker, that means the process of filtration is taking place, where we're basically filtering the solid away from the liquid. We're separating them. So the process here is filtration. And by the way, the name of the solid that remains here is, we call this a residue. The name of the solution that remains down, we call it filtrate. This is a must know. Now, the general name for the solid in step 3 is residue. State the general name for the solution obtained from process in step 3. We said the solution from filtration, the solution we get, we call it filtrate. Okay, so it says two more steps. Okay, so in filtration, oh, sorry, actually, let's see the question. Two more steps. Step 4 and 5 are needed to obtain a pure sample of barium sulfate. In each of these steps, something is removed from the residue. State what is done in each step of 4 and 5 to identify a substance removed from barium sulfate. Okay, so in step 4, after filtration takes place, there are two things we need to do. We need to wash with distilled water and dry. So these are the two steps: wash and dry. Okay, and then now substance removed. Now, so to decide the substance removed, we need to look at our reaction. So here we have so our products is going to be sodium chloride and barium sulfate. Now the student is looking forward to make barium sulfate. He doesn't care about the sodium chloride, so he needs to wash it, he needs to remove it. So we're basically going to remove the excess sodium chloride, because by the way this is a product, so we need to remove the product. So we need to remove all the excess sodium chloride by washing with water. I spelled chloride wrong. Chloride. Okay, and the substance removed will be sorry, wow, I wrote it in the wrong place. We will remove sodium chloride. Okay, now when we dry, we are going to remove the water that we washed with. So we're already done with the water, we don't want any more. We're going to dry, so we're going to remove water. And that is it. Now, for the rest of the past paper, it is very easy. Just measure, and that's it. It's very easy, and graph. And make sure that also, if it asks you if it asks you a question, for example, if we use a polystyrene cup, what is the advantage of using a polystyrene cup, or what happens? Just know that polystyrene is a good insulator. So it helps reduce heat loss, and it helps, so basically increases the temperature. It increases the temperature, it reduces heat loss, and it what's it called? It maintains the temperature. It helps maintain the temperature. And that's it. So that's it. That's all you need to know for the ATP exam tomorrow. And good luck.